So in this video, we're going to talk about the effects of reaction rates. All right. And we're going to look at that, basically there's several things that you can be done to help reactants overcome the activation energy barrier and therefore speed up the chemical reaction. And there's three things that you could do specifically, or three things that you could change in order to increase the rate of reaction. All right, and those three things that you could change are temperature, concentration, and finally, catalyst. So let's talk about each of these three. So let's first talk about temperature. All right, so temperature is basically, the actual definition of temperature is the average kinetic energy of a substance, right? And so when you think about temperature, if you were to increase or raise the temperature of a substance, all right, you're basically adding energy to the reactants. All right, so to the reactant itself, if you were to raise the temperature, you're adding energy to the reactants. By adding energy, okay, or specifically kinetic energy, all right, what's happening is that the reactants are now moving faster. If they're moving faster, then essentially what's going to happen is that you are increasing the frequency of collisions. All right, you're increasing the frequency of collisions. And because, now they're moving faster, so more likely over some period of time, there's going to be more collisions. Not only that there's going to be more collisions, you're also increasing the force of collisions. So like when you're thinking about it, because they have more energy, all right, they're hitting each other more often, and they're hitting each other harder more often because there's more energy, all right? And so due to this, it makes it much more easier, much more likely that it's going to overcome the activation energy barrier. Now, the point that's really important here is that the amount of activation energy doesn't change due to temperature. All right, you just make it easier for the reactants to reach the activation energy. All right, hopefully that makes sense. So you can't lower, or by changing the temperature, you're not lowering the activation energy. No, you just make it easier for the reactants to reach the activation energy. All right, and so really interesting fact, typically for most substances, if you increase the temperature by 10 degrees Celsius, you are doubling the reaction rate. All right, so this oftentimes is the case. All right, so the next factor that can affect the rate of a reaction is concentration. So as the concentration of a reactant increases, okay, typically the rate of reaction will increase. Why? Well, you're increasing the frequency of collisions. Okay? So, like, what does that mean? Well, if you have more substances within some unit area, right, or some unit volume specifically, right? If you have more particles per unit volume, then the more likely these particles are going to collide with one another. And every time there is a collision, there is a chance a reaction will take place. Okay, and so you could kind of think about it in terms of, like, if you're talking about like car accidents, all right, the likelihood that you will collide with someone on a highway is much higher at 3 p.m. versus 3 a.m., right? Because at 3 p.m., you got a lot more people on the road, versus 3 a.m., there's a lot less people on the road. So the likelihood that you're going to collide with somebody, it's much greater at 3 p.m. So thus, as you increase the concentration and there's more particles per unit volume, then there's more likely that there is going to be a collision. And when there is a collision, there is always that chance that the collision will be successful. Thus, a chemical reaction will take place. All right, the last word that we're going to talk about are by catalysts. Now, catalysts increases the reaction rate either by letting a reaction take place through an alternative pathway with a lower energy barrier, or by orienting the reacting molecules accordingly or appropriately. So catalysts are the only factor that actually lowers the activation energy. Okay, so it actually physically lowers activation energy or the barrier itself. Now, how does it do that? It does it by several different ways. So it's either that the reaction goes through a different pathway, which doesn't need as much energy to take place, or it orients the reactants accordingly, so that way it's just much easier for the reaction to kind of take place. So, in other words, a way that you could kind of think about this is that, so like, for example, let's think about like if a reaction to take place, and I'm just kind of going to use an example, right, between two people who could potentially fall in love, right? Person A and person B, all right, for them to be a couple AB, okay? Now, a catalyst could be like a matchmaker, right, where my catalyst is Y. All right, and my catalyst is what brings the two reactants together so that they could meet. All right, and so then when the reactants come together, meet because of the catalyst or because of the matchmaker, really, then then there you go, you got yourself a couple, right? And usually anybody, some of you guys may have that experience where that you were like the centerpiece between two individuals, and that's how they met, and all of a sudden they're in love. Well, then you are the matchmaker, you are the catalyst. You allow them to meet each other faster. I mean, they could have on their own, they may have taken longer, right? But you are that I guess that gravity that put them together. And so catalyst is pretty much the same idea, really. All right. In some cases, it allows the reactants, they will orient the reactants together so that way they could react. Okay. Now, in terms of energy profiles, all right. So if you have your reaction that goes this way, and then your free energy is going up this way, right? So if you were to consider a uncatalyzed reaction, all right, so this may be an example of an uncatalyzed reaction. Now, if you take that same reaction, right, and you add a catalyst to it, it may look something like this. All right. And so now if you were to pay attention, so we could see that between this point here and this point here is your activation energy without a catalyst. Okay. But then you see that between here and here is your activation energy with a catalyst. So we see that the activation energy has been lowered. And so due to the fact that the activation energy has been lowered, then the reaction is going to proceed faster. Now, one thing to note, the delta G between these two remains the same. Okay, so it simply tells us that the reaction was going to take place anyways, with or without the catalyst. Okay, so a catalyst doesn't cause the reaction to take place. The catalyst just makes the reaction move faster. Okay, so with or without the catalyst, delta G will be the same regardless. In this case, because it's exergonic, this reaction was going to be spontaneous regardless. All right, now the fact that you add a catalyst, the chemical reaction just happens much faster. All right, so like a good example of this, of something like this, is that, and some of you guys could actually YouTube this, but hydrogen peroxide All right. It's an exergon. The decomposition of hydrogen peroxide is exergonic, where it's going to make water plus oxygen gas. All right. So this typically kind of happens on its own, and I'm gonna balance this because I just feel like it needs to be balanced. So this is aqueous. This will be liquid. That'll be a gas. All right. So if you buy, even when you buy hydrogen peroxide, and half the time the reason why it is in this dark brown, bottle, is trying to decrease the rate in which hydrogen peroxide will decompose, right? Because it decomposes with very little energy. All right. But this process takes place naturally on its own. Okay. And so if you purchase hydrogen peroxide and you leave it over a long period of time, like years on end, then the amount of hydrogen peroxide that you had in that solution will be much less because much of it have decomposed. Okay. Now, you could actually speed up this process. All right. You could add potassium iodide. If you add potassium iodide, you see that you speed up this process thousands of times. All right, to the point that you could actually just watch it bubble and stuff like that. You could also add manganese manganese peroxide, or sometimes it's called manganese dioxide. All right, so if you add manganese peroxide, it's like this black powder to the hydrogen peroxide, you're going to speed up this process thousands of times over. All right. So as I said, the reaction is going to take place with or without it. But when you add a catalyst, and like this, the reaction I gave you between potassium iodide or manganese dioxide, if you add a catalyst, then this reaction is just going to happen much, much faster.